Welcome to Teaching Raw. Today our topic is finite automata. Yet another method for defining languages. Previous tutorial we learned how can we make regular expression and now finite automata. Definition: a finite automata is a collection of three things. Number 1, a finite set of state, one of which is designated as the initial state. One is initial state like state A, and negative signs show its initial state called the start state, and some may be none of which are designated as final state. And state B, positive signs show final state, and we can take transition A B like this, add loop on A, add loop on B. This is the meaning of first point. Now let's move on second one. An alphabet sum of possible input letters. Sum of possible input letter we can consider input letter A, B or C, what we want. Now let's move on. Point number 3, a finite set of transition that tell for each state and for each letter of input alphabet which state go to next. What it mean? I will written example of this point. It's mean each and every point have all alphabet transition possibilities. A and B. B is our final state, A is our initial state. This is, if we pass A on state A, it will go on B. B is our final state. And if we pass B on state B, it will go on state A. And transition B is not defined in state B, and transition B A is not defined on state B, and transition B is not defined on state A. So we can write loop here, complete all transition of state A, and like this, complete all transition of state B. We consider for this finite automata only two alphabet, A and B. Let's move on some example questions. Here's some example question of finite automata. Let's move to the questions. Here 5 points for draw a finite automata. Let us start for first point. Here X, Y and Z, 3 states. So firstly we draw 3 state. State X, and here written X initial state and Z final state. So negative sign show initial state. Here another state name is Y, and last state is Z, and we know that Z is our final state, so positive sign show final state. Now start transition of states. From state X and input A go to Y. X input A to go to Y. Okay, like this, and pass the variable words letter A. From X input B go to Z. Input B go to Z. And third one, from state Y and input A go to state X. input A go to X, from state Y and input B go to Z. This is, and last point is from Z any input stay at Z. It's mean loop here for B and loop for A. Any input stay at Z. We can also write one loop and AB comma. This is our first example question. Let's move other example questions. Here another example question. Question number 1. Write finite automata which accept word double A or double B as a substring. Double A or double B as a substring. Here solution of this finite automata. State A has initial state. Initial state show negative sign, and state B is another state. State C is another state, and last one is state D. State D is our final state. If we pass A from state A, it will go on B. And if we pass A on state B, it will go on state D, except double A as a substring. Okay, if we pass B state A, it will go on C, and if we pass B on state C, it go on state D. Double A or double B is acceptable, but if B comes on state B, what happen? It will comes on state C. What happen? A comes on state C, it comes on state B. And what happened? AB comes on state D, it's always stay on state D, A comma B, or we can write two loops individually for A and B. This is the answer of finite automata of this question, and we can write RE also like this: A plus B clean closure and bracket double A plus double B yes, this is double B. Okay, I will remove this. Okay, double A or double B, apply bracket, and after double A double B, A comes many times or B comes many times, so A plus B and clean closure. This is finite automata FA of this question, finite automata, and this is RE of this questions. Thank you for watching this video.